Previously we've talked about proving triangles congruent, and we had various methods to prove triangles congruent. In this section we're going to prove triangles similar. Okay, there are three main reasons you can use to justify that two triangles are similar. We're going to look at one of them, which is angle-angle. The angle-angle similarity postulate states that if two angles of a triangle are congruent to two angles of another triangle, then the two triangles are similar. So let's get another triangle here. Now you'll notice that the two triangles have the same shape. Actually, their angles are congruent, so I'm going to mark, say this angle is congruent to this one, this angle is congruent to this one. And what we are saying is, if two angles of one triangle are congruent to two angles of another, then the two triangles are similar. So these two triangles are similar. And you might ask yourself why the third angle is not needed. Well, common sense, if you use your common sense, you'll figure out that if two angles of a triangle are congruent to two angles of another triangle, that the third angles are also congruent to each other. Just remember that the sum of the angles of a triangle is 180. Furthermore, if two triangles are similar, if two pairs of corresponding angles are congruent, then we do not need to know the measures of the sides or the third pair of angles. So all you need is two pairs of angles congruent. But once you know that they're similar, then you know that corresponding sides are in the same ratio. That is the definition of similarity. So let's look at this problem here. Determine whether the triangles are similar. So, well, at first glance you see that angle Y is 53, and it may appear that the two are not similar. However, if you solve for angle Z in triangle XYZ, you will see that you got 90 plus 35. The measure of angle Z equals 180. So that's 125 plus measure of angle Z equals 180 degrees. Subtract 125, subtract 125, and now I just made that up to be 35. That should be 37. So let's go ahead and fix that. That's a 7, that's a 7, and that's a 7. So that's 37, 37, 127. So the measure of angle Z is 180 minus 27, and measure of Z is 53 degrees. So I'm going to mark this here. This is 53 degrees. Aha! Now I have my two congruent angles. Let me just highlight those, this one and this one. And then I have that one and that one. So the two triangles are now similar by AA. And if I was to write my similarity statement, I have to be sure that this is in the correct order. So I would say angle Y. I don't mean angle Y. I would say triangle Y, similar triangle. So I'm going to look at the angles. Y is to A, X is congruent to B. So YXZ is ABC. YXZ, I got that right. So those two triangles are similar. And it will follow that you will get a statement of proportionality, and you will get YX over AB equals XZ over BC equals YZ over AC. We don't need this right now, but this is for future reference. Okay, show that the two triangles are similar. Okay, which two triangles are we talking about in the left hand side? Well, the inner triangle and this is angle Q. Angle Q is common to triangle PQR. It is also common to SQT. So if I was to write a similarity statement, it would be that triangle QR is similar to triangle SQT. Okay, over here in this diagram on the right, these lines are actually parallel. So when you have parallel lines, remember you have alternate interior angles are congruent. These are vertical angles, they'll also be congruent. So the two triangles are going to be congruent, and I'm going to write the similarity statement. Triangle FEG is similar to triangle FJH. Let me not forget that. Okay, number 3 is a word problem, and I'd like you to do that yourself. What you should start off by doing is drawing a sketch, and maybe I'll start that off for you. What you want to do is, here's your building. The building will have a shadow on the ground, and hopefully your building is at 90 degrees. So this is the shadow, and your building is, the shadow is 26 feet long. And then at the same time you have a student. So this is your student here standing on the ground. Well, maybe we should have him touching the ground, huh? There. We'll give him some arms too. Okay, this student is 71 inches tall, and the shadow here is 48 inches. So you want to find the height of the building. In other words, you want to find B. So go ahead and set up a proportion to solve for B, and figure out what your answer should be, and I'll put that in a call out.